In this video, we are going to discuss C-nested structures, focusing on structures inside other structures. Nested structures are structures that contain other structures as members. This allows for complex data organization and hierarchical relationships in C programming. Think of it as putting boxes inside other boxes to organize your belongings. Let's explore the syntax for nested structures. Here's the basic syntax. We start by defining an outer structure using the struct keyword, followed by the name of the outer structure. Inside the outer structure, we declare members such as outer member 1, which is an integer, outer member 2, which is a float, and then we embed an inner structure. To embed the inner structure, we again use the struct keyword, followed by the name of the inner structure. Inside the inner structure, we declare members like inner member 1, which is an integer, and inner member 2, which is a character. Finally, outer member 3 is also declared as a character. Note that the inner structure is defined within the outer structure. Here's an alternative approach. First, define the inner structure. For example, let's create a structure named address, containing members like street, as a character array of size 50, city as a character array of size 30, and zip code as an integer. Then use this inner structure in the outer structure. For instance, let's define a structure named person, containing members like name, as a character array of size 50, age as an integer, and address, as a structure of type address. Let's explore how to access members of nested structures. Here's a complete example. We start by defining a structure named address, which includes members like city, as a character array of size 30, and zip code, as an integer. Then we define another structure named student, which includes members like name, as a character array of size 50, role no, as an integer, and address, as a structure of type address. In the main function, we create a variable s1 of type student. To access and assign values to the members of the nested structure, we use the dot operator. For example, to assign the name John to the name member of S1, we use strcpy s1.name, John. Similarly, to assign the roll number 101 to the roll no member, we use s1.rollno equals 101. To access the members of the nested address structure, we use s1.addressCity to assign the city New York, and s1.addressZipCode to assign the zip code 10,001. Now, let's see how to work with an array of nested structures to manage multiple records. Let's start by defining the address structure, which includes city as a character array of size 30 and zip code as an integer. Next, we define the employee structure, which includes name as a character array of size 50, ID as an integer, and address as a structure of type address. Now, in the main function, we can create an array of 3 employee structures named staff. To access the first employee in the array, we use staff0. To assign the name Alice to the name member of the first employee, we use strcpy staff0.name Alice. Similarly, we can assign the ID 1001 to the ID member using staff0.id equals 1001 and set the city to Boston and the zip code to 02108 for the address of the first employee. When working with nested structures, consider using typedef to simplify structure declarations. Initialize structures with designated initializers for better readability. Also, consider memory alignment when designing nested structures. Use pointers to structures for large data to avoid excessive copying, and create functions that operate on specific structure types for better code organization. Let's discuss advanced techniques and real-world applications of nested structures. One advanced technique is using typedef with nested structures. For example, we define an address structure with members like street, city, and zip code. Then we define an employee structure with members like name, ID, work address, and home address, both of which are of type address. In the main function, we create an employee variable named manager. We can then access the city of the work address using manager.workaddress.city and the city of the home address using manager.homeaddress.city. Nested structures have numerous real-world applications. They are used in database systems for modeling complex relational data with parent-child relationships. In graphics programming, they are used for representing hierarchical scene graphs with nested objects. File systems use nested structures to implement directory structures with nested file metadata, and network protocols use them for defining packet structures with headers and nested payloads. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.